Alright, and hello and welcome back to our OneClass channel. Again, my name is Joey. I'm going to be your math teacher for this session. So OneClass, what we've been going through is we've been going through kind of a session of verifying solutions for commonly asked questions in both the mathematics and also in chemistry. What we've been doing is we've been teaching you concepts through frequently asked problems. So in this session, what we're going to do is we're going to focus mainly on math, and we're going to do questions in the pre-algebra, algebra 1, and geometry type of questions for today. Again, my name is Joey. I'm currently an Ontario school educator, and my teachable subjects are chemistry and mathematics. So I have about 11 questions for us today for the hour, and we'll go through those questions together, and I'll teach you through the concepts through those questions. So let's get started. All right, so our first question of the day is what is the cube root of 1,000 here? So let's answer that here, and it's asking what is the cube root of 1,000? So I want the cube root of 1,000. Or is that asking what is the cube root of 1,000 here? So what we can do is we can actually rewrite this as with a term, right? We can say the cube root. So if we know a square root of 1,000 looks something like this, a cube root is something, if you stick kind of like a 3 in front of the or before the kind of root kind of sign here, that makes it a cubed root. So similarly, a square root is something in terms of it's the same number times the same number equals the number inside the square root. So in this case here, or I'm not going to use 1,000 for example. So for example, if we're using a square root of 100, let's say, it's going to equal, I know that the square root of 100 here equals 10 because 10 squared is 100. So that's kind of my relationship between this and square roots. Or sorry, 10 squared, not 100 squared here. 10 squared is 100, right? So similarly, when we talk about cube root, we're talking about 3 numbers multiplied together to get the same 3 numbers multiplied together to get the number inside the root. So I'm asking, it's going to be some type of number cubed. So it will equal the number, will equal 1,000. So I can rewrite this as, okay, what is x cubed equals 1,000, or what is this? What does this mean? So we can say that, and again, they have to be the same number, right? It has to be like 1 times 1 times 1, or 2 times 2 times 2 equals some number here. So how we can solve this problem is we could use kind of basically two kind of different logics here. What we can do is we can do a trial and error for us to figure out what the cube root of 1,000 is. So I'm looking at this cube root here, and I'm looking at, okay, the 2 numbers that probably would go into this number, or what would be divisible by, would be either 5 or 10. And what we can do is we can take the cube root of those numbers and see if we get 1,000. So if I had, for example, if I had 5 cubed here, or I'll say 5 and 10 here, I'll say our factors of 1,000. So what we can say is we're doing a trial and error method. So this is a trial and error. And what we can do is we can say that, okay, we can say that, what is 5 cubed? Well, 5 cubed would be 5 times 5 times 5, which would equal 25 times 5, which is 125. And 125 is not 1,000, so 5 cubed must not be the correct answer. And I'm going to try 10 as well. So I have 10 cubed here. This is going to equal 10 times 10 times 10, which is 10 times 10 is 100 times 10, which is 1,000 here. 1,000 is actually the number inside the bracket, so therefore it is 10 cubed here, right? So therefore I can say that 10 cubed equals 1,000. So therefore the cubed root, so I can cube root both sides here. So I can take the cube root of both sides, and then I would get 10 here. It would equal the cubed root of 1,000 here. And this here is my correct answer. So the answer here is 10. The cube root of 1,000 here is 10. And what they did was they kind of did the same thing here. So they kind of used trial and error to figure out that 10 times 10 times 10 equals 1,000 here to the power of 3, and then they just took the cube root of both sides here. So this solution here is correct. Good analysis as well. It's actually in a new format with these guys here, so I think it's actually a lot nicer, which is nice. I like the black theme here, which is cool. I think it was a different theme before. So number 2, how do you write 3/8 in percentages? So I want 3/8 as a percent. So when we look at percentages, what do we have to do? Well, we want to convert, we can either convert this guy into, we can multiply it by 1,000, or we can convert it to a decimal first. It's honestly up to you as to how to figure out this answer. So in this case, if I want to do one direct step, what I would do is I would actually do 3/8 multiplied by 100% here to convert it to a percent. And if I didn't have a calculator, what I would have to do is I would have to kind of reduce these terms, right? I know that both these terms are divisible by 4. So I can say that this is divisible by, this here is simply 2. This here is simply divisible by 4, which makes 25 here. And I can't simplify those any further. So I would get this percent. I get 3 times 25, which is 75. 75 over 2 here percent, and this would equal whatever 72 divided by 2 is. And I can do this on the side here, some side work here. So what is 75 divided by 2? Well, I'm simply just using long division, right? So 2 times what number goes into 7? Closest is 7. This would be 3. 3 times 2 here is 6. 7 minus 6 here is 1. And bring down the 5 here. 2 times what number is closest to 15? I know it's 7. Is closest to 15. This will be 1, and then I have to add a 0 here to bring this down. So it's 0. 2 times 5 is equal to 0, right? And I'll have a decimal here. 10 minus 0. So my answer here is 37.5. So this answer here is 37.5%, and this here is the correct answer for my solution. And what they did here was they actually converted to decimal first, and then they converted it into a percentage. So either way works fine. I just did mine in one step because I'm allowed to change this into percent. I just have to simply multiply by 100% for me to change this to percentage here. And all I had to do was do the long division for whatever 75 divided by 2 is, which is 37.5%. So the solution is correct. As you can see, they got the solution correct as well. Okay, number 3. How many cups are equivalent to 1 pint? Cups in 1 pint. So again, what we're doing now is we are measuring that we are working in the imperial system. And we are measuring volume here. So what we want to do here is we're looking at the imperial system. So let's write down our conversions for what we don't want to know, and then what we can do, what we know already. What we can do is we can find some type of relationship between those conversions. So what we have here is 1 gallon. I know it was 4 quarts. 1 quart is 2 pints, and 1 pint here is 2 cups. So as you can see, we can see our relationship between pints and cups here. And we actually don't have to do any work for this problem because it's already given in our conversion factor. It's asking us cups in 1 pint. We'll know that 1 pint here equals 2 cups, right? And this here is actually our answer for this problem because I don't have to do any math because again, this case here is already based on the original conversion. So I don't have to multiply or divide anything for this problem. So therefore, you can say that there are 2 cups in 1 pint. And this solution is the correct solution. So there are 2 cups in 1 pint, which is correct. Okay, number 4. How do you find the square root of 324? So I want to find the square root of 324. So in this case, you could either, again, two methods you can use. You can use the, you can again use trial and error. Actually, there's 3 methods. Sorry. You can use trial and error. You can use a prime factorization, or you can use the method solution. So, or the long division solution. So I'm going to use the prime factor. I think I'm pretty sure I've answered this question before, but we can go through it. So I want the prime factors of 324. So let's do it. So we have the square root of 324. I can break this down into a root 2, and I'm going to divide 2 out of this number here. So 324 divided by 2 would be, I'm going to see if I can do this in my head. I think it's 162. No, that's the I can't do it in my head. 2 times 1 here is 2. 3 minus 2 is 1. Bring that to 2. 2 times 6 is 12. 0, 4. Oh, it is 162. Cool. Okay, so 162. Cool. It's just side work here. But it was just me dividing 324 by 2 here, if you're not given a calculator again. So this here is root 162. And then I can break down this root 162 even further. To 162 divided by 2, I believe, is 81. 2 times 8 here is 16, and 2 times 1 here is 2. Root 81. And then I know that root of 81 is one of my special square roots, because I know this is a perfect square. Well, 81 here is simply, root 81 here is simply just 9 times 9, right? Or you can say it's simply just 9, because I know that 81, I'll write this here, 9 squared equals 81, so therefore 9 equals the square root of 81 here. Because these are one of the perfect squares that I know. Usually I like to memorize the perfect squares from 1 to 10, and those give you a good basis as to how to approach these problems here. So if I know that 9 equals root of 81, I can simply just say that root of 81 equals 9 here. What I can do now is I can group these together. So I have root 2 times root 2, which is simply root 4 times 9. Root 4, I know it's 2 times 9, which will equal 18. And 18 here is my answer for this problem. If you want to be really, really specific, you can say this is plus or minus 18 here is the square root of 324. And as you can see, the solution is correct because you have plus or minus 18 here. So the solution is correct. Okay. Number 5. How many ounces are in 500 milliliters? So what I want to do is I want to be able to convert between two systems, because right now I want ounces, and I'm given a milliliters, and this is in metric. So I'm going from basically the metric system, which is in milliliters, to the empirical system, which is in ounces. And both of these guys are measuring volume here. So we have to know what a conversion factor is for us to figure out the relationship between both systems here. So and usually I don't think you have to memorize these types of conversions because they are kind of a bit more tedious to memorize. But I know that in my conversion system, I know that 1 milliliter equals 0.0333814 ounce, as given also in the solution here. So we're on the right track. And what we want to do is we want to convert 500 milliliters, right? So what we want to do is we want to, again, use this concept of unit analysis. So if I'm beginning with 500 milliliters, so I have 500 mLs on this side, I'm going to multiply by our conversion factor, right? And I know that there's 0.033814 ounces per milliliter. So you can say 0.033814 ounces in 1 milliliter. So I know that the milliliters here cancel out. So I can say that it's simply just 500 times this conversion factor here of 0.033814 to get us our answer, which is going to be 907 ounces. And this here is our solution. And as you can see, this solution is also correct because they said 16.907 ounces in 500 milliliters. So solution is correct. Number 6. Which axis shows the symmetry of the graph of the function? Let's see. Which axis shows the symmetry of the function? And I have f of x equals x minus 2 squared plus 1. So what I want to do here is I'm looking at which axis shows the symmetry. So I'm looking at what is either the x or the y-axis that shows the symmetry of the function f of x equals x minus 2 plus 1 here. So what we want to do with this function here is we know actually the vertex of this function because this function is currently in vertex form. It's something you learn kind of in algebra 1 or in grade 10. So we know that this function is in vertex form. And how do we know that? Well, it's given by these two coordinates here. So I know that the vertex of this formula of this equation here is 2 and 1 here. So if I were to kind of graph this, and you can solve this actually graphically or algebraically, it's kind of up to you how you solve this problem here. But if I were to draw a graph of this function, I know the vertex is 2 and 1 here. So I can kind of estimate here, this is 1, so here's 2, 1. So this is kind of the vertex of the formula here. And it can either open upward or open downward. And in this case, because my a value, and this here is the imaginary a value, right? This guy here is the imaginary a value. It's equal to 1 in this case. It's actually positive. So I know that my parabola is going to open upward. So you can say that the parabola looks something like this. It looks something like this, and it won't open downwards because it's not reflected in the axis here. So again, it's asking us which axis shows us the symmetry. So let's look at the solution and let's see what they're doing here. So it says we have the following function. Okay, that's good. So they graphed it, which is good, and they actually solved for the y-intercept here. So actually, it's probably a good thing to solve for the y-intercept as well. So let me just solve that for you real quick. Because this graph is technically inaccurate without the y-intercept. So let me just, because we only know the vertex here. So let me solve for the y-intercept for you as well. So honestly, all you have to do is just set our x value to 0, right? So to solve for our y-intercept, we're going to solve x here equals 0, right? So we can say that f at 0 is going to equal 0 minus 2 squared plus 1, 0 minus 2 squared plus 1. This is 4 plus 1, which is equal to 5. And as you can see, this here is at 5, right? So we can say that this here, maybe like somewhere up here is 5. So we can say it's something, it looks like that, looks like the parabola here. Obviously, I didn't draw it very nicely, but this looks something like the parabola here. And as you can see, it's the parabola is something like that. And then what they're doing here is now they're saying the vertex is a 2 and 1, which is good. So we know it's in vertex form. And we know the line of symmetry is x equals 2, which is parallel to the y-axis, right? So again, the question was asking which axis shows the axis of symmetry. So actually, let me draw this a bit better here. And it's actually very hard to draw because my graph isn't my graph isn't to scale here. That might be the best thing to do here. But what I'm doing is which one shows the symmetry here. And what you can do is you can actually draw a dashed line here right at the vertex for you to figure out that these two places are supposed to be symmetrical. It doesn't really show it in my diagram, but both of these sides here are symmetrical. So meaning that so this means so I'm going to write a therefore statement. Therefore, at x equals 2, you can say it shows the symmetry of the function. It shows symmetry of the given function. And this here is our answer. X equals 2 is our answer. And this is correct as well. And the reason why we know this is because we can draw a dashed line at x equals 2, and we know that this side is symmetrical to this side. So when we say symmetrical, we can say that if it's reflected along x equals 2 here, it's going to be the exact same curve or the exact same function between both of these sides. So if we reflect this side onto the left side onto the right side and the right side onto the left side, it is the same function here. So this solution here is correct. And we actually didn't really need to solve for the y-intercept. They just did it just to show proof of point in terms of graphing. But we really just care about, in the vertex form, really we care about the vertex, right? So this is 2 to 1. And we know the axis of symmetry it basically goes, in this case, it would go right at the x coordinate here to divide the kind of parabola in half to make it symmetrical. So the solution here is correct. So it says convert 2.5 into a fraction and a percent. I think that's number 7, right? Yeah. So let's do fraction first. So 2.5 into a fraction. So I have 2.5 here. I have 2.5. I know that this part here is the whole number part. So this is whole. And anything after the decimal here is the fraction part, right? Or the decimal part. And in this case here, it's in the tens digit, right? Because I know that this is in the first place of a decimal, so it's in the tens digit. So I can rewrite this as a mixed fraction. I can say it's 2 here as the whole part, which is 2. And then it would be the denominator here, and I'm writing the fraction now. It would be the denominator here is 10 for the tens digit in the decimal, because it's in the first place of decimal. And the numerator is simply just whatever is the decimal. So in this case here is 5, whatever is in the decimal here. And then what I can do now is I can convert this. This is now a mixed fraction. I can convert this into an improper fraction by simply multiplying in the whole number. So I can say 2 times 10 here. So 2 times 10 here is 20. And then I'm going to add the numerator. So 2 times 10 here is 20 plus 5 is 25 over 10. And this here is 2.5 in a fraction, which is great. And then what I want to do now is I want to convert 2.5 into a percent, right? So let me do that at the bottom part. So I'm giving 2.5 now as a percent. I want to find 2.5 as a percent, right? So I'm going to multiply this by 100% for us to figure out what the percentage is. So again, 100 times 2.5. So you can kind of split this up. You can visualize this as simply just 2 times 100% plus 0.5 times 100%. So 2 times 100 is 200% plus 0.5 times 100%, simply just half of 100%. So this is 50%, which is going to equal 200 plus 50 here is 250%. And this here is our solution this is the answer to the question here. So 25 over 10 is in the fraction form, and as you can see, this is 25 over 10, which is great. And then 250% is the percentage form. And what they did was that they actually reduced this to lowest terms. So actually, I think I like that better. So let me reduce this to lowest terms for you. 25 over 10, what I could do is, if I were to reduce in lowest terms, I would I would basically divide them by the greatest common factor. 25 and 10, the greatest common factor in this case is 5. So this is going to equal 25 divided by 5 here is 5, and 10 divided by 5 here is 2. So you get 5 over 2 here is the reduced form of the fraction, and they got 5 over 2 as well, which is actually really, really good. And 250% is our percentage form of the given number. So the solution here is correct. That was number 7. I think we asked this question before on number 8. Let me go back. 1 pint is cups. Yeah, this was the exact same question. So I think I actually put this question up on purpose just to double up here. It's asking how many cups are equivalent to a pint. So again, I asked cups here is equivalent to pint, and again I said that this was in the imperial system. It's in measuring volume, and then I just wrote down all my conversion charts. Right? So I have 1 gallon equals 4 quarts, 1 quart equals 2 pints, and 1 pint equals 2 cups. And in this case here, we don't really need to do math because it's the answer is already given in our conversion factors here. So it's saying here that how many cups are equivalent to 1 pint. Well, no, that 1 pint here equals 2 cups. So that you can say that therefore there are 2 cups in 1 pint. So the solution is correct. Okay, so that was 3. I guess that's also question 8 as well. So that was question 8. So I guess this is now question 9. So 8 was just a repeat of 3. 9 here is asking us which of the following is equal to 12. So I have 4 options here. I have the square root of 144, the square root of 100, the square root of 124, and the square root of 81. Well, right off the bat, what we can do is we can actually get rid of 2 of these numbers here, right? So we can say that, we know 2 of these square roots. Square root of 100, we know this guy equals 10. So we can say immediately B is the wrong answer. And square root of 81 here is equal to 9, right? And this here is the wrong answer. And the reason why I know this is because 10 squared equals 100. So therefore, the square root of 100 is going to equal to 10. And 9 squared equals 81. So therefore, the square root of 81 will equal 9 here. So I know that I know these guys right off the bat. So I can say B and C are wrong. So it's between A and C here. So let's work this out. So let's look at A. And again, we can do prime factorization for A here. And we can actually use some type of logic here. We can say that because the number in the square root here is bigger than 100, therefore the square root of 144 needs to be bigger than 10. So the next kind of even number after 10 would be 12, right? So let's look at 12 and let's see if this equals 12 here. So I can say that I can either say that, and there's two ways of thinking here. I can use prime factorization to figure out if this is 144, prime factorization to figure out if that's the correct answer, or I can simply just use trial and error. In this case, I would actually just use trial and error because 144 is a pretty common square root. So I'm going by the logic that 144 is bigger than 100, so therefore that the square root of that number has to be bigger than 10. So I'm going to try 12 here. So I'm going to guess 12. And then we can just do simply just 12 squared. So it does 12 squared. If 12 squared equals 144, then square root of 144 equals 12. And what we want to do is we want to solve for 12 squared. So 12 times 12 here. So 2 times 2 is 4. 2 times 1 here is 2. I add a 0, and I say 2 times 1 here is 2. 1 times 1 here is 1. I add those guys together, I would get 144. So this here is actually correct answer. So we can say the square root of 144 is equivalent to 12. So this guy equals 12. So A here is our correct answer. So as you can see, the solution here is correct. So it says if you take 12 squared, you get 144. So therefore, the square root of 144 is equal to 12. So the solution is correct. Okay, number 9, 2 more questions. Number 10, it says out of 30 questions. Out of 30 questions, Ahmed answered 12 of them incorrectly. It's asking what percent of the questions did he answer correctly? Did he answer correctly? Okay, so I have out of 30 questions. And again, there's two ways of doing this. So I can kind of do this question both ways. So it says out of 30 questions. Out of 30 questions can be divided denominator. Ahmed answered 12 of them incorrectly. So 12 out of 130 are incorrect answers. So these guys are going to be the fraction here will be my incorrect answers. What we can do is 12 out of 30. We can convert this into our percent, and we can solve for this problem here, right? So if I multiply 12 out of 30 by 100%, I will get this. I can cross out a 10 here, so I can have 3. This would be a 10. 12 times 10 here is 120 divided by 3, which is going to be 120 divided by 3 here is 40%. So 40% of them are incorrect answers. So therefore, what is the percentage of correct answers? Well, I can simply just say that, and again, a percentage is out of 100%, right? So 100% is going to equal the number or the percent of correct answers plus the percent of incorrect answers, right? I know that this is going to equal, well, I don't know this guy, so I can say that this here is x or something like that. So let me say that let x here. Let x equals percent of correct answers. And I can simply just say that 100% here is going to equal x plus percent of incorrect answers, and I know it's 40%, right? 40% is this guy here. So I simply have to just isolate for x, right? So I can say that x here is going to equal 100. I can subtract 40% for both sides, which will give me 60%. So I can say, therefore, Ahmed answered 60% of questions correctly. And this here is our solution. And as you can see, this is the solution as well. So this is a good solution. Another way of thinking about this problem is how they thought of it. So they thought of it as 12 questions of Ahmed were answered incorrectly, he answered 18 of them correct, right? So you can take the total amount of questions, which is 30, and subtract the amount of incorrect answers to get the amount of correct answers. So 30 minus 12 is 18, and then they took this percent. So I would have 18 divided by 30. You multiply that by 100%, which would equal 60%. So either way, both of these logics will work. It's up to you how you want to solve this problem as well. And let me just do that logic for you as well. Oops. So again, I would have 30, which is the total amount of questions, minus 12, which is the number of incorrect answers, to get 18, which is the number of questions of correct answers, right? Correct answers. And what we can do is we can say now 18 over 30 will give us our percentage or fraction. We'll multiply that by 100% to give us our percent. And again, you can cross out the 3 here and cross out a 10 here. And you can divide both of them by 10 first before you do this kind of thing. 18 times 10 here is 180 divided by 3%, and this is equal to 60%. So again, both of these solutions make sense, so you can do that as well. So this is equal sign, sorry, equals 18. So the solution is correct. And then finally, I have one last question. Yeah, this is number 11. How many feet are in a football field that's 100 yards? So I want feet in a football field that is 100 yards. So again, I'm working in this is in the imperial system. This is measuring length. So I'm looking at the imperial system. So what are the conversion factors? Well, I know that 1 mile equals 1760 yards. Now 1 yard here equals 3 feet. And what we can do is we can actually stop there, right? Because we're looking at yards to feet here. So all we have to convert from we have to just simply convert from yards to feet here. So we can say that our conversion factors are going to be, I have again 100 yards is what I'm starting with, and multiply that by how many feet are in a yard? Well, I know there's 3 feet in a yard, right? And I know that I want my yard at the denominator, so I can cross out the units. So therefore 3 feet will be at the top. Yards cancel out. So I have 100 times 3, which is simply 300. And I have feet left over, which is feet. So you can say, so this here is our correct answer, and we can say that therefore there are 300 feet in 100 yards. So the solution is correct because they wrote 300 feet as well. Solution is correct. Good analysis. So that's actually 11 questions for the day. We do have some extra time, so I'm probably going to see if I can kind of put a couple more questions for us to do, maybe 1 or 2, and then we will call it a day. Just give me a second as to how I would do those problems here. Let's do 2 more problems, and we'll call it a day here. So let's see. Solution is correct. Select 2 more for us for today. So let's do 5. Let's do this one. Let's do a systems of a linear equation question. Let's do this one as well. All right. So let's do this problem here. So I guess this will be our new question 1. And I loaded up 2 more questions for us to do here. So asking us, what is half of 1/3 cup? Give me a second here. What is half of 1/3 cup? So again, this here is just saying that you have half of a third of a cup, right? So they used some type of pie chart here to figure out what this is. But what you can do is you can actually solve this algebraically or with fractions. And what you can say is, so it's asking us, I want half of a 1/3 cup. So I'm saying half here is simply just half, so 1/2. And it's of 1/3. What's half of 1/3? I'm going to multiply, right? Half of 1/3 would get me what is half of 1/3 of a cup here. So I'm multiplying half by 1/3 here, which is going to equal 1 times 1 here is 1, 2 times 3 here is 6. I'm going to get 1/6. So this answer is going to be what's half of 1/3 of a cup? Well, it's simply just 1/6 of a cup here. So the solution is correct. What they're doing is they're dividing by 2 or they're multiplying by half, right? So I thought of this as multiplying by half. So therefore, half of 1/3 cup is equal to 1/6, 1/6 of a cup. So the solution is correct. Good analysis. Finally, my last question of the day is number 2. So I have a systems of linear equation question. So it says linear system of 3x plus 5y equals 10 and ax plus 2y. 2y equals b. Has an infinite number of solutions. So it has, I have infinite number of solutions. So find the values of a and b. So in order for us to solve this problem, we have to say what does it mean when we have an infinite amount of solutions? Well, in systems of linear equations, geometrically, we have two lines, right? So I have one line here, and you can say I have another line. It could cross at a point, right? So I know that this here is a point of intersection, so there's one unique solution. So whenever there's an infinite number of solutions, I am talking about one line and another line basically right on top of this singular line here. So I have two lines on top of each other, which will give me an infinite amount of solution. So in order for us to do that, how do we figure out this is going to be an infinite amount of solutions? Well, I have to make both of these equal to each other. So in order for us to do that, what we can do is again 3x plus 5y equals 10, and this is we know all the numbers in this kind of linear equation, but we don't know a and we don't know b in this one as well. But we know that 2 here, so we can work with this 2. So we can say that 3a, what we can do is we can actually divide kind of all of these guys into an equation here. So that's what they're doing here as well. So they're dividing everything. They're dividing this equation by this equation here. So you can get 3a equals 5 over 2y, or actually it's simply just 5 over 2, right? Because the x's cancel out, equals 10 over b. And what we can do now is we can create some type of equation here. So I'm going to use these first two guys here. So I have 3a equals 5 over 2. And I can say that if I wanted to isolate for a here, I'm going to multiply a by both sides here. So I get 3 over 5 over 2a, which means that a is going to equal 3 times 2 over 5 here. So a is going to equal 3 times 2 is 6. It's going to be 6 over 5. So a here is equal to 6 over 5. That's great. And then what I can do also is I can do this on the right side of the equation, right? I can also say that this blue guy, 5 over 2, is also going to equal 10 over b, right? And then all I'm going to have to do is isolate for b. So I have 5 over 2, I'm going to multiply b by both sides, which equals 10. And then I can isolate for b. So b here is going to equal 10 times the reciprocal of 5 over 2, which is simply just 2 over 5. So b here is going to equal 10 times 2 is 20, divided by 5 here is simply just 4. So this here is our correct answer for these two problems. So a here is 6 over 5, and b here is 4. And as you can see, this here is the correct solution as well. So solution here is correct. Good analysis. So we finished 13 questions today, more than I expected, which is great. I think there was also a repeat as well on one of the questions, but that's totally okay. So again, thank you so much for watching the stream. Again, my name is Joey. I'm a OneClass teacher here. I stream Monday to Fridays. Basically Monday, Wednesdays, and Fridays are my math days, and then Tuesdays and Thursdays are my chemistry days. So you can kind of check out the videos there. And again, thank you so much for watching. Stay safe, stay healthy. Have a great day. Take care.